Yep, just started it. Go ahead.
Okay, awesome. Hi, everyone. Welcome to our next CIB Purdue seminar. So today is our last seminar. We're going to finish it with one of the best women researcher in the world. So today it's our honor that we host Dr. Burcin Becerik-Gerber from University of Southern California. So she's the Dean's Professor of Civil and Environmental Engineering and also the Department Chair at USC. During the last 15 years, her research focused on advanced data acquisition, modeling, and visualization for design and construction and control of user-centered, responsive, and adaptive built environment. She pioneered a very innovative field and new field in our community about human-building interaction, which is actually the convergent field that represents the growing complexity of the dynamic interplay between human experience and intelligence in built environments. She published more than 150 peer-reviewed journal and conference papers. She got like millions of dollars funding from the state and federal agencies, not to mention like NSF, DOE, DHS, and Department of Transportation. She received several awards nationally and internationally, such as MIT Technology Review as one of the top 35 technology innovators under the age of 35. So she has like a different types of award, a very, very long list, and but she is one of the researchers in our construction, engineering, and management community that serve as a role model for many of the new faculties. And it's our pleasure to have you here, Dr. Burcin Becerik-Gerber. So floor is yours.
So again, thank you so much for that wonderful introduction, as well as the pre-conversation we had prior to the lecture. I appreciate the welcoming remarks. And I see Dulcie also in the audience. Hi. I have many friends in Purdue, so it's a great pleasure to be talking with you. So I changed the presentation title a little bit. I would like to, and the essence of the presentation is the same as my lab's work, which is around human-centered, and I'm considering to change it also to life-centered. It's an evolving thought as we make progress with research, intelligent built environments. So as Sogand introduced me, I have spent a large portion of my academic career at USC. Started as an assistant professor, and I'm in the last 3 years I've been the chair of Civil and Environmental Engineering Department. So my group is called iLab, Innovation in Integrated Informatics Lab. And we are very much focused on technology centered approaches for intelligent built environments. But I would like to start with this slide, and this is something I discuss very much with my students. Yes, in my lab, we use all kinds of technology, from sensing to VR to simulations to machine learning. But I always ask my students, technology is the answer, but what is the question? I always like starting with the research questions, and we're very technology agnostic. And I mentioned this because we're part of the CIB here, and I'm also part of computing and civil engineering group. So yes, there's a heavy focus on technology, but there needs to be a purpose why we're implementing these technologies. For me, it is how to use computing in support of individual and societal good. And for me, again, to narrow down this question, it is about implementing technology for individual and societal good within the built environments. As Sogan mentioned, we started this human building interaction field that has 3 pillars: human performance and well-being, enabled by technological sensing and awareness, as I will be talking throughout this seminar today, and implemented during building design, construction, operation. So this is a diamond that we have developed with 25 authors coming from multitude of disciplines, from social science to computer science to many disciplines of engineering to health sciences and such. But at the center of this diamond is those individual and societal goals that I mentioned: equity, privacy, sustainability, and security, safety. You can name other goals that we all work towards as researchers. So why does it matter? Why does human building interaction matter? Or why do intelligent environments matter? So I put here 4 different images. What you see here is, it doesn't matter what the built environment is. It could be a construction site or an office building, a hospital or an airport. Built environments have to be providing the necessary infrastructure to support human needs. What I mean by that is not just the shelter or the immediate function of a built environment, but it could be health and well-being, for example, in an office environment. Obviously, there are several of you with construction engineering background. Safety, productivity are very important. The way that I think about these intelligent environments are an extension of their occupants or their users. So they can self-learn, predict, adapt, and change both the user and the building behavior. And I'm thinking about these buildings or built environments as machines that interact with users in a natural way. Again, there's always a reason and there's a purpose, right? They're reasoning with a purpose. And those could be user satisfaction, comfort, productivity, and energy efficiency. So several goals that we try to fulfill through the intelligent built environments. And it's an amazing area because we spend majority of our time indoors, and there's so many different building types or built infrastructure types that fulfill so many different engineering goals. So I started with this introduction. I'm going to continue with some work examples from my research lab, not getting into the details, staying high level, and trying to explain this human building interaction and the various individual and societal goal objectives through my research. So one line of research has always been focusing on worker or occupant well-being in intelligent built environments. So this has been a long line of research. Actually, I started my career with this, and I had several amazing students worked in this area of thermal comfort, how to sense this condition of mind that expresses satisfaction with the thermal environment with minimum input from the users. This is one slide with probably 3 or 4 PhD students' work, and you can see from this image on the right bottom side, this is pre-thermal cameras, but we've been working on this from participatory sensing to sensing to understand and model occupants' thermal comfort preferences so that we can operate buildings based on personalized preferences rather than standardized set points. So we've done a lot of research in terms of mathematical modeling of comfort, not only in the thermal comfort area, but the other comfort areas as well, and also developing algorithms to implement in building operations, specifically heating, cooling, and ventilation, air conditioning, HVAC, heating, ventilation, air conditioning systems. One thing that we have realized, even though we are able to save energy, depending on the location of the building, of course, the climate, as well as the building construction, The way that mechanical systems are designed, specifically in the United States, when we have more than 3 or 4 occupants in the same thermal zone, because of our varied preferences, we cancel each other's requests, because there could be somebody who's liking warmer environments and cooler environments, very likely in the same thermal zone. So that led us to thinking about office buildings in a different way. If thermal comfort or personalized environments are important, we started thinking, rather than relying on the centralized systems, can we rely on the local systems to provide comfort, personalized comfort? So this is collaboration with Aruf, a global design and engineering firm, and they designed this desk that has sensing embedded within it, and this is a piece of furniture that you can find any office, and we decided to rethink the typical workstation. So, and this is also a long line of research. What we have done in the end is, once we building these desks is not that difficult, but we have a lot of existing desks as well. So we wanted to build all of these sensors in a sensor box, and we model people's thermal comfort preferences. But what you see at the bottom here is also people's automation preferences. So we have operated the local fan and the heater per occupants' preferences, but on top of that, we had intelligent agents that work with the occupants to work with their automation preferences, and these preferences could change from full automation to no automation, inquisitive automation that asks you what you would like, to adjusted autonomy, which learns your preferences and adjusts your preferences of automation and thermal comfort as you go, and updates itself online, because the situations within a built environment changes as well alongside with your preferences. With this research, we got really also interested in ergonomic comfort and posture, which is a well-researched area. However, there are we found several gaps in terms of office buildings where there's occlusion and it's not as controlled as some controlled experiments we have found in the literature. And we work with our occupational scientist colleagues to understand not only what is a poor posture, but also how long you have to be in that poor posture before the desk or the building to communicate with you, to have some kind of an intervention for healthy musculoskeletal system. And this is, I'm sure, if you're an office worker, something you have realized quite a bit. Then what happened during this research is the pandemic. And we had to go to our homes and adopt our home offices immediately in California overnight, and most of the country as well. So we got really interested in how people are adapting their home offices, because it was pretty ad hoc and pretty quick. So we did one of the first national surveys in April 2020 to understand office environments' impact on productivity and well-being. One thing that came very significantly was the stress. And of course, there were so many different reasons for this, right? Overnight, stay-at-home orders were issued, and we had to adapt our work environments, our family situations. So stress coming from that, as well as stress coming from uncertainty. But then when we dug into the survey, we also realized there's a lot of stress within built environments, specifically related to office work. So we got interested because there are so many similarities between thermal comfort and stress, if you think about it. But when you think about stress, you think about the negative stress. And most of the research done using machine learning has taken into account this negative stress. But there is also this positive stress. I'm sure you have felt the stress that where you're stressed, but you're very productive. Maybe you're working on a proposal and you're getting an incredible amount of work during a short period of time, and that is called eustress. The first one is called de-stress. So we were very interested in how built environments could empower eustress and reduce de-stress. So we started a new line of research looking at physiological sensing, understanding the physiology of an occupant and how stress is manifested, both on the de-stress and eustress, and behavioral signals as well. And this was, and everything I'm going to present, I'm going to stay very high level. And if you're interested in, I can send you the papers and we can have separate discussions. So we have run some very controlled experiments. I believe this was with 50 office workers, where we put them in a low stress and a high stress condition. And we used data coming from human-computer interactions, from facial expressions, from posture, as well as physiological sensing, electrodermal activity, heart rate variability, and such. So this is a graph, and I have an easier graph for you to see. But what I would like to show you is this line here, more or less. Stress's relationship to productivity. We also looked at mood and stress and how it maps to boredom, eustress, de-stress, and eustress and stress. So this is let me go to the next slide. This is called the Burcin and Dawson law, and we mathematically proved that this also works for eustress, de-stress phenomena. So when there's no eustress or de-stress in the environment, your productivity is very low, so you're bored. When eustress increases, then your productivity increases. There is a period where eustress and de-stress coexist, and then de-stress takes over, and this is the moment where you are not anymore productive and feeling this de-stress. So this is all good, and I'm going with huge, quite speedy. So that research, once we were able to differentiate and predict eustress from de-stress, we got interested in how buildings affect stress, creativity, attention, and productivity. And there's a long line of research in my lab, and we looked at various things, including sense, including noise, including lighting, and stress, built environment as a creator of stress, and also as a relief to stress. So there's several indoor environmental quality factors actually impact us in this realm. And you see here, even on the right side pictures and the left side pictures, I'm sure different emotions are triggered when you look at those images. Most of our work and most of the work in the literature, so this is a little bit of self-criticism, has been lab experiments, short-term experiments. From there, I got really interested in, like, can we actually replicate some of these results and understand the built environment's impact on stress in longitudinal studies? So we received a relatively new NSF grant, Smart and Connected Health Grant, in which we're now looking at 30 of our office workers over 6 months and collecting, again, physiological, environmental, those are all the IAQ factors, as well as materials, as well as colors, as well as patterns, as well as other office properties, attributes, and behavioral data, and continuously monitoring office workers through ecological momentary assessments to be able to understand impact of built environments on stress. Of course, well-being is not limited with stress. There's so many factors in the built environment that impact our health, from lighting and colors to air quality to ventilation and sound and noise. And we have actually an international network also funded by NSF, where we bring in networks looking into well-being in the built environment together. So with that, I'm gonna pause that line of research. I want to take you to another line of research where human building interaction is also important, and that is emergency preparedness and response. I know this is a little bit of a hard shift, but I wanted to bring to your attention various human building interaction examples from my lab. So as you know, there are numerous disasters, man-made or natural disasters that we're exposed to with climate change. We have extreme events, more frequent than before. I was interested in understanding how built environments impact our response during these emergencies. So this is a collaboration with Alan Turing Institute and Tsinghua University with one of my former PhD students there, where we build virtual environments to understand architectural visibility and also following behavior, along with some other features. And we collected data in London, in Los Angeles and Beijing, also to understand cultural differences that affect built environments' impact on emergency response. We use in this line of research virtual reality quite a bit. The reason for that is high ecological validity and also the difficulty of replicating these events. And this one is from an active shooter simulation, where we have simulated office buildings and school buildings, and we had a standard version of these buildings alongside with enhanced version. An enhanced version included countermeasures that were recommended by various agencies, like staggered doors or reduced hiding places or some other architectural features. And we looked at teachers, and we recruited teachers in these experiments and office workers' behavior. And it is very interesting. Both our roles as well as the type of building that we're in, even the perception of the type of building we're in, affect our response. And some of the countermeasures implemented in that in recommended work actually in the opposite direction of impacting human behavior. So this is research. Again, one door of research opens another door of research. This is a Department of Homeland Security grant where we are looking at healthcare environments where nurses and doctors and other personnel are responsible with other people's lives, for other people's lives. And we have developed a training environment where we looked at immersivity and interactivity and the impact of those features on learning. And this is currently my student, actually, as of today, completed or will be completing data collection, and will be looking at the impact of this very specific environments and the training on the response of occupants. So this led us to another exploration. We have most of the research that I have shown you so far is our human subject experiments. So we bring participants to the lab, and we do control experiments. We have collected tremendous amount of behavioral data, and we wanted to use that data in simulations, because simulations give us an avenue for exploration. And this is a new grant we recently received, actually 2 different grants. One is, again, Department of Homeland Security grant, where we will be looking at architectural design and impact of architectural design and different typologies on behavior. And another grant, Smart and Connected Communities grant from NSF, where we will be working with our campus communities in 2 campuses, with one of my former PhD students in FIU and at USC, specifically developing simulation solutions for first responders using realistic human behavior that we have collected in our previous experiments. So with that, I am going to move to another line of research again. And I'm going to talk about human-centered approaches for technology-enabled construction sites. Again, the work continues in another environment, and this time construction sites. So as you can see in this slide, there is a SAM, a semi-autonomous masonry machine, building a wall. And I have this slide because in each of the slides you see humans, right? Workers, either working alongside the robot or doing some quality checks, feeding bricks to the robot. So as we know, and I mean, there are strong construction researchers in this group, that construction sites are not likely to be completely autonomous, at least in the near future. So what we see is this human-machine collaboration for hybrid activities, and this is where, in my mind, construction sits, where humans complement machines with difficult tasks for machines, and also machines or AI gives humans superpowers and augmenting their abilities. The picture on the left side is a picture I took on my way to work. And it says robots can take your job if you're already retired. The idea there that I was very intrigued about this is the fear of automation and the fear of AI. And this is actually a picture probably from 5 years ago. So if humans and human workers and robot workers have to work alongside or side by side, what does it mean for our workers? So that's a project that we have completed. I only have one slide on this, but we worked on a VR-based training environment that incorporated adult learning theories to reskill and upskill construction workers. So that this training had 8 modules, and here you see a construction worker. Actually, this research was conducted during pandemic, which was very difficult to bring construction workers to the lab. And we trained half of the workers with our VR-based training, half of the workers with traditional training, in-person training, and we put all of them in a performance task using a real robot. We wanted to understand the impact of VR-based training on knowledge acquisition and knowledge transfer to the real environments. And we also wanted to understand the workers' safety behavior and skill when they're trained with VR-based training, and also understand trust in automation, situational awareness, and mental workload when they were trained with virtual reality. And there's so many lines of there's so many papers that I can share with you. But this research led us to the next one, where we realized when you're teleoperating or remotely operating a construction equipment, there are so many sensory information. There's so much sensory information that you are missing. So this is another grant, Future of Work grant from NSF, where we're looking at what are some of the sensory informations that is necessary to be provided and what are some of the ways we should be providing this information to construction workers. So this is we're taking a different approach here. We have a stakeholder engaged approach where we're developing the technology with construction operators, construction manufacturers, and construction managers, constantly receiving feedback from them at each step. And this is ongoing research right now in my lab. I'll very briefly talk about user-centered approaches in teaching as well. This is a course that is dear to my heart, and I co-designed and co-developed. Unfortunately, because of my department chair duties, I'm not able to teach anymore. But this is a multidisciplinary class focusing on innovation in engineering and design for global challenges. Last year and this year, our instructors are focusing on Ukraine, the war there, and they have taken students to the border with Romania. In the first two cohorts, we focused on refugee crisis, and we took our students to Lesbos, Greece, which experienced one of the most difficult situations in terms of migrants and refugee situation. So we follow design thinking in this class. And what is interesting for me in this class is taking the seat of the user, right? Understanding the problem from the user's perspective. We took the students twice to site. The first one was for understanding the users and the problems, because these are wicked problems. Usually what you see on the surface is not the real problem. Then the students came back, and we're talking about engineers of all kinds working with non-engineers, students from architecture, students from public policy, students from sciences or cinematic arts. Then they have prototyped. There's rapid prototyping as part of this class. And now we took them back to the refugee camps to test their products with the end users, NGOs, and the other government entities and the refugees themselves. Throughout this process, we had a documentary actually crew following us, because we were so interested in the pedagogy, and we wanted to communicate that to others. So we produced a documentary called Lives Not Grades, and here is the link that you can still watch it. It was aired by PBS, and it looks like it got really good ratings, and it was recommended for or nominated for Emmy. And actually, I am holding a real Emmy there. We received an Emmy, which is something that I could have never thought about. So with that, what is next, right? Technology is reshaping our everyday experiences, from social robotics to virtual agents to autonomous cars to intelligent, smart environments. But it is really important for us to think about, if you have seen the Space Odyssey 2001, we have to steward human needs. And also the planetary needs when we're thinking about development of AI. I'm involved in two initiatives which are very high-level initiatives. I'm part of I'm API to NIOSH, where we're looking at how AI should be implemented within work environments with occupational safety and health in mind. And I'm also involved in New European Bauhaus, where they're developing principles, indicators for all construction projects to be evaluated against three objectives: aesthetics, sustainability, and inclusiveness. And these are all not only construction projects, but also technology enabled projects. So with that, I'm going to, and it gives us a little bit of time to discuss, but I'll leave you with this idea and take you back to where I started. To harness the full potential of technology for the betterment of humanity and our society, we have to integrate individual and societal objectives in the very fabric of technology advancement. And I think it's our responsibility, each one of us who are working with technology, to think about this in the back of our mind. How can we better individual and societal goals with every step that we take? So these are some of my current and former students whose research that I have shared with you, along with my collaborators. You will see, as Sogan at the very beginning mentioned, from learning scientists to health scientists to social scientists to computer scientists. Really, I enjoy working with this interdisciplinary group of people. Without them and my students and the funding agencies, of course, this work would not have been possible. With that, I'm going to stop and maybe even stop sharing, because you're seeing the slides, not me, and take any questions that you might have.
That's awesome presentation. Thank you, Dr. Becerik-Gerber. So we are now gonna open the floor for questions. Please feel free to unmute yourself and ask your question. Yes, go on, Dulcie.
Thank you for an inspiring presentation, Dr. Gerber. So I just have, and every time I listen to you, I'm saying, wow, this is amazing. You're moving on to yet another domain in which you're also having impact. I didn't know about the Emmy Award that you received. I don't think I had heard about that until right now. So of all the studies you've done, I mean, you've mentioned some of the challenges, particularly the challenge of doing some of the work, particularly during COVID. Now, in addition to that, what other challenges have you faced when you've been trying to work across different stakeholder groups?
Yeah, that's a very good question. Thank you for asking that. I hope that my answer is not going to be too long, but I want to cover all the challenges. I mean, COVID was, I think, one particular disruption that came to all of our lives, and I mean, it was a very interesting experience for all of us. But I think one of the challenges of this work is it's very multidisciplinary, and bringing all of these disciplines together takes quite a bit of time. And I don't mean it just from the perspective of finding the right people, of course, that's important, but also finding the right questions that interest them, right? And that requires flexibility and a little bit of compromise, because they're not always interested in what I am or we are interested in. They want to also answer their questions from their discipline perspective and have a contribution there. So it is a compromise, but it's a worthy compromise, in the sense that I feel like when they bring in their questions to my questions, or add to my questions or our questions, then it becomes really enriched and completely different things that I've never even thought about. But that does take a long time, and that is numerous meetings, and even like setting the language correct, right? We are not always talking the same language. Finding these funding agencies that would accept, more than a couple PIs. As you know, in this area, we don't have very large grants, unfortunately. So that does take, it's one challenge. The other challenge, I don't know if this is a challenge anymore, because my group is a little bit more established, but at the very beginning, students didn't know this field, and I had to convince them, and we had to work together, and they had to take these classes outside of civil engineering and computer science, or in design, or in psychology, whatever they needed to do. it is a challenge, I think, for students, but it takes a certain personality of a student. It could be also very rewarding as well. And another challenge that I realized we have been working a lot with users, right? You've seen a lot of participants coming, and we're getting data collected from them. But most recently, almost all of my work has taken this approach of the stakeholder engage approach. Like we not only we have researchers, let's say we have 6 researchers, in almost all of my grants, we have equal number of practitioners now, providing real world feedback, like this teleoperation, right? It's a very exciting one. We're thinking about like how to provide haptics, how to provide visual cues, how to provide noise, and they're coming up with really very practical problems of like, how are you going to do this? The construction sites are very dusty, or we need to really understand the outriggers and where they're going to be placed. I mean, so now I have this challenge of keeping the research rigor, but also making sure that it's also the research can find its way. So it's not to just please, myself, and I love asking questions and answering questions, but also it is applicable to them, people who are taking on this work. I think I would say these are the main challenges. Other than that, I can't think of anything else. I'm sure there are others. And if you have something in mind that I didn't mention, please feel free to ask.
Thank you.
Any other question? Oh, there is Freddie, go on.
Hi, thank you, Doctor, for this great presentation. So my question is regarding the thermal comfort in built environment. So in the research experiments that you showed that for collecting data from the occupants, especially the ergonomics information, I see that you've used cameras and bands. So I was just wondering when it will have to be like replicated or scaled to an actual office. Will there be a drawback with the invasion of privacy, or was that only for the experiment, and for an actual office, will it be a different system or interface?
That's a good question. Privacy is it's not just with the cameras, right? Everything we're collecting. Right now we have participants wearing these Empirica watches, and we can tell what they're doing, and I mean nonstop, right? Heart rate, ETA, skin temperature, you name it. I mean all kinds of very private information, and you can infer a lot of health non-research related also activities and health information as well. So privacy is definitely important regardless of the sensing type you use. With that, I mean, that's a larger conversation, and we always give the right to the participants, right, in terms of how we will use and what we will use, and they can opt in and opt out of and what data that we can have access, what granularity. So this is our solution, giving the data back, or the rights of the data back, to the owners of the data. And as researchers, we have to manipulate or work around that. And that means sometimes missing data, sometimes one set of data for one and not for the others. And it's our responsibility to develop methods around that. But also working with users quite closely, one thing that is important to them is the value. So if you can prove a piece of value to them, right, that understanding their own behavior, or understanding their own health, or understanding the impact of the built environment or their habits on something important to them, then they are more willing to give you the data, or not give you, but let you use the data. So that value proposition has to be there, right? It cannot be just for answering a research question, but there has to be a value back to them as well. So we're investigating that now. Actually, next week and the following week, we're going to have focus groups in the first cohort of occupants that we collected, office workers we collected data from, to show them some of their data and show them some of their patterns to understand what kind of information they're also interested in. And what we can do in the second cohort to provide that information to them in a more meaningful way. Sorry, Preti, I'm not giving you a very direct answer because this is a very difficult question, right? And it's not just a research question with everything we're using, from generative AI to social media to you name it, right? In a building, even if it's not used for research, tens and hundreds of sensors, you're nonstop providing your information. So that is something we have to, again, it goes back to the beginning and end of my presentation. As researchers and technology developers, we really have to have in mind safeguarding human and planetary needs.
Right, right. Thank you, Professor. Thank you.
Funded
Let's
projects.
see. Any other question? You don't need to raise hands, just unmute yourself and ask.
Yeah, I have a question.
Go on.
Thank you, Professor, for this great presentation. You covered so many topics and different disciplines. I'm interested in your approach when you explore a new research area or different, specifically like different discipline. What's your approach in attracting funding? I mean, do you start research and then look for funding, or do you ask funders for their interest and then start the research to get the funding? What's your approach?
Oh, that's a very good question. You made me think. Almost, first of all, where I start is almost always from a personal interest. I don't know if it's selfish, but I'm really interested in the topics that I have a self-interest. I mean, all of these research projects and the 3 that I have given you example came from, I mean, construction one is more from my background, and, you know, I would say that's where I'm grounded. So that is more of a natural one. The thermal comfort one was, you're going to laugh at me, but it was, the poor building, the building, and how badly operated it was and how uncomfortable it was for me. What was happening was, actually, I was an assistant professor in this thermal zone where next to a tsunami researcher, and he had his servers in his office and he has the thermostat in his office, and he wasn't there most of the time. So the system was sensing heat in his office. And I was the first one in the duct system and getting all the cold air, and I'm there, poor assistant professor, always there freezing, and I'm like, enough with this, I need to really figure out something about this. The active shooter and emergency one, again, I am a mother of 3, and 2 of my kids were in a lockdown in their elementary school, which as you can see here, I mean, if you can even hear in my voice, to this date, I'm very disturbed, and as a mother, I was really concerned about what's going to happen. And that was like, okay, I cannot do anything about gun control, I'm not a politician, I'm not in political science, but I know the building, so what can I do to help this problem, right? Or at least to shed light into this problem, because there are so many millions of dollars being spent in schools. And when I looked at it from a designer engineer perspective, they seemed counterintuitive to me. Okay, but that you didn't ask that question. You asked, what do you do? But I started with like where these research interests come from. So I do, and it is intimidating, and it's a little scary to start a new line of research. What I first do is a lot of reading. I do tell my students, if you're not reading at least 1 paper a day, you're behind. and I try to walk the talk as well, though finding time is becoming difficult, and learning the field and learning the people who should be who we should be collaborating with and approaching to those people. But at the same time, I would not be honest if I don't say to you that I also look at the funding opportunities, because let's be real, right? If you don't have money, obviously you're not going to be able to fund that research. So I try to align my research interests with the funding agency's interests as well. So there is that alignment, and then there's the alignment with your collaborators. So there's quite a bit of alignment, I guess. But then I do work on proposals over a very long time. I don't write proposals in 3 weeks or 4 weeks. I cook the ideas quite a bit and work on those ideas. Yeah, long time, I would say. So that's, I don't know if I answered your question, but those are some of the things that I have done.
Yeah, thank you.
That's awesome. So very good, good guidance for the students that we have here, and they want to go to academia. So you got just rule of thumb and very good advice from Dr. Gerber. Any other question?
And I think on that note, success is very simple, and this is not my recipe. Actually, the previous chair who hired me, JP Barde, not previous, 2 chairs before, drew a Venn diagram on my whiteboard, actually, when I was an assistant professor, of 3 circles, and one of them was your skills, right? What you know, your technical skills and what you're trained in. Obviously, you have to have those skills to be able to be successful. The next one was funding, and as I mentioned, obviously you have to have funding to implement these ideas. And the last one was your passion. If you're really not passionate about an area, if you have skills or funding, it's not going to be as successful. And he told me just to be in the middle, and I thought that was a fantastic advice.
Awesome. Shiva, you can go ahead and unmute.
Hi, can you hear me?
Yes, we can hear you.
Hi, Professor Burcin. Very, very nice presentation. I really enjoyed that. And as Dr. Sogen mentioned, you are a kind of role model, specifically for women in engineering and civil engineering. So I would like to ask the question about the thing that you mentioned about at first, I mean, we have the technology, and technology, there are different kind of technologies that we can use, and there are different kind of tools. And the main thing that we need is to be able to define the research question. That is the main thing. So do you have any suggestion that how we can find the best research question?
First, don't start from the technology. That's a bad recipe, because I had many students came to me and said, I want to do VR. I want to do machine learning. I'm like, okay, so for what? It's like, I want to do machine. So that conversation really doesn't go anywhere, because they don't know what they want to do. They just want to use VR, right? Or whatever that technology is. I think you have to be really insightful. You really need to understand where the field is going, and that means you have to read a lot outside of your field. Right? I mean, you look at from popular articles to consultancy reports to agency directions to White House reports. I mean, you really need to get a pulse of where the field is going. And I'm not talking about construction engineering field or structural engineering field. I'm talking about the general direction. And then I think you need to look at the societal needs and directions, right? That's also very important. extreme events, extreme conditions or disasters. I mean, you're seeing this like what every week in the news channels, something's happening somewhere in the world. So I mean, that's the type of societal need I'm talking about. And that was the angle that I got back to construction after a break, right? All these technological advancements being implemented, and now you realize the workers are left behind. So my comeback to that area of research was like, how could we train these people, because they're essential. So, and then also you have to really listen to your heart, like what you're interested in, right? I mean, there are research topics that you will never be able to sell to me. I'm like, that's not my research topic. I'm not going to do that. Right? You have to be passionate about the topic, as I mentioned before. So I think it's a combination of things, but I think first and foremost, you really need to have an interest. Because I don't know if you're in a PhD program, if you are, is 4 or 5 years of your life, presumably you're doing this to be a researcher after you graduate. That's really long time of doing something that you're not interested in, right? You really have to think about what you are, that brings joy to your life.
Yeah, you're right. Thank you so much.
Awesome. Any other question? As you're thinking, maybe I will ask it. So, Dr. Gerber, where do you think where we are going in construction? What is going to happen in like a couple of years from now? You're just doing all this research about the future work, but how is your perception and your opinion about where we are going, and how our students need to prepare themselves for what we will experience in the future of the construction and built environment?
Oh, that's a difficult question. I don't think we're going in the next 5 years somewhere we don't know, right? I mean, you're feeling it, where we're going, but I think we are at the call, like intersection of like having disruptive technologies finally being introduced to construction. The ideas were there, but the level of technology development was not necessarily there in terms of implementation cost and maintenance costs and readiness of technology. So I think we are going to see more automation, and we're going to see more maybe off-site construction or rapid construction methods being introduced. It's not probably going to affect all types of construction projects equally. I think there will be some that would be impacted before others. But in general, I think my recommendation is to stay current with the technological developments. It's going really fast, and be as technology savvy as you can. At the same time, make sure that your core skills are also developed, and those are the core engineering skills I'm talking about, not just programming, coding, and things like that. And other skills that are extremely important. I mean, we didn't talk about team building, and we didn't talk about communication, and other skills that we take as granted, but are extremely important, right, to be successful in life in general. And if I were to give one advice to all of the students here, don't stay just in your area. I mean, I mean that, right? If you're in construction engineering, please go to an environmental engineering seminar. If you're in structural, go to I don't know, hydrology seminar, whatever it is. I think you really or stay. Why would you stay within the department? Go somewhere else. Try to use. You're in the university setting. There's so many opportunities. Try to take advantage of those opportunities, not from a very narrow point of view of your sub-discipline, but from a broader perspective. Obviously, you don't have a lot of time, and everybody's time is limited. But I think we can do much better than developing a broader perspective than being too narrow. Sogan, I have to leave
That's
to
awesome.
another meeting.
Yes.
I apologize.
Yes, I know that you have another commitment right after this one.
Yes.
So awesome. So with this one, I think it's better to just finish on time. Thank you so much, Professor Becerik-Gerber. So that was a pleasure to have you, and then that was a very, very excellent presentation. Also, Professor Abraham needed to leave and then send me a message to tell you that thank you so much for engaging with us, and thank you so much for the excellent presentation. And we look forward to have you back for one of our seminars and next semesters, and this time in person. And thank you so much, everyone, for joining the seminar. And so with that one, we will wrap it up. Thank you.
Thank you. I appreciate that. I would love to come see you all in person. And if there are any questions, send me an email.
Sure. Thank you so much. Bye.
Mohammed, great seeing you.
Yes, the same here. I'm sorry. I apologize. I was in a prelim exam, took longer than we thought, and I came late. I got some of the questions, but I know that a person that